Yeah, friends, back to my session. In previous session, uh, we have discussed how to do the basic data analysis for our data set, which is the behavior study of students who are in 10th standard, right? We have done the analysis with frequencies and summary of the data has been discussed, right? Yes. Now we do the data analysis for the same data set. I mean, for the same data set, we mimic our data by using some statistical methods or inferential statistic tools with SPSS, right? Yes. Now we are taking one practical exercise. The practical exercise is having different questions or statements in lines of statistical methods and inferential statistics, right? Yeah, you have a data set with 15 variables. That is behavioral study of the students, right? Yes. Now my wish is to test is there any relationship between two categorical variables. One is academic achievement and another one is achievement motivation, right? How you how can you examine the relationship between these two categorical variables? Yes, yes. In general, in order to test the relationship or an apparent connection between two measured or qualitative or categorical variables like academic achievement and achievement motivation, we can use a simple statistical device or tool, that is correlation analysis, right? The correlation analysis will helps you to find the relationship between or to test the relationship between these two categorical variables, academic achievement and motivational achievement. Fine. Yes. Now, how you can test or examine this relationship? Just you set up statistical hypothesis, or you call null hypothesis simply. There is no relationship between academic achievement and achievement motivation. Or simply you can say that there is no association between academic achievement and achievement motivation. Fine. Now, how you can test this hypothesis using correlation analysis, right? Just I'm going back to my SPSS data file or data set what we have extracted in the previous session, right? Now here I'm taking my data file, okay, which was already stored or saved in my SPSS data editor. Fine. So that file is yes, this one. Yes. Now my SPSS data file related to behavioral study of the students has been opened. Fine. Now we are in variable view window. Now data view window is this, right? Yes. Yes. For this, now what to do, right? Our interest is to test the relationship between these two categorical variables, no? Yes. Now you go and analyze on top menu. Just now I have opened my analysis, that is analysis board. Now you analyze. Okay, what we want to analyze, we want to test the relationship between the two categorical variables. That's why we need to take help of the correlation, right? Now come to that. You have only two variables now. This means your data set has two tuple observations, which is nothing but the bivariate data. Okay, your data set is a bivariate data, right? Now you can click on that. Fine. Now here a pop-up menu has been displayed, right, with the list of variables, and another one is an empty window, uh, that is variable window. Okay, what are the study variables now? The study variables are, just I'm going back this. The study variables are academic achievement. What is academic achievement? That is class division, right? Academic performance though, right? Yeah, achievement motivation. You have achievement motivation variable or scores. Fine. So now you can take these two. One is achievement motivation, please. Yeah, just you click on that, and now that will be enter into your study variable window. Okay, now another one is another variable is that is class division. No, yes, now I'm taking that one. So this is nothing but academic performance. Our niche is to test the relationship between these two. No, so that's why I'm taking these two. Now you go to options. Fine. So if you want to know the mean and standard deviation, like descriptive measures, you can click on that, right? Now see, continue. Then our interest is to find the relationship between them. No, now there are different approaches, right? Correl Pearson, coefficient of correlation, then Kendall's, then Spearman rank correlation, like, right? Here I am taking the first measure, Pearson correlation. Okay, that is Pearson correlation will give you now the relationship or association between these two variables, right? So on the other hand, if you want to test the validation of the data, the validation of relationship which you are obtaining using the Pearson, you compare with these two also, right? That is Kendall and Spearman. If you can use these two, then you know the validation of the significant relationship between these two. I'm not taking these two, just my concentration is on now Pearson coefficient of correlation, which is significant or not. In between these two variables, you will know. Fine. Now, okay. Say okay. Fine. Yes. Now in output window, in output view, the output is a display. What is the output? Descriptive statistics and correlation. Here are the descriptive statistics. That is achievement motivational score, mean score is 14.99. Standard deviation score is 3.842. Number of cases are strength, class strength. Okay, that is your capital N. Strength of the class is 100. Fine. Now the division, that is academic performance, right? Academic achievement, no issue. So mean achievement, mean performance is 4.22. Okay, and the standard deviation is 0.610. Just I am concentrating on the means of achievement motivational score and the division. Okay, so the average score of all the students achievement motivational score is 14.99. Fine. Yeah. Whereas the division or academic performance is 4.22. Please try to understand the concept. Academic performance we have given for our five options. That is less than 39, he will get fail. 40 to 49, he will get a third class. Okay. So like that, 70 and plus, you may get the first class with a distinction. Fine. In that way, the score, mean score is 4.22. So this comes under first class. This means what? So most of them are in that class of first class students. In that way, you give a little conclusion about the descriptive statistics for achievement motivation and as well the division or academic performance or achievement. Fine. Yeah. Now comes to correlation. Our interest is to test the correlation between these two, no, achievement motivation score and division. You can have a look. So here achievement motivation with the division, achievement motivation score with achievement motivation score with the division, right? What is the relation? You see that is 0.127. It is very less because you know very well the correlation coefficient is in between -1 to +1, right? Yeah. So now if this is positive, zero, it is in between 0 and 1. Okay, but it is very less. Okay, just you can see whether this value is effective or not, means the value is significant or not. Okay, you can you can see that is significant. So significant value is 0.210. The significant value is nothing but a p-value. So p-value is nothing but a probability value. This probability value will give you an idea about so far is there any relationship between these two categorical variables, right? So basically we prefer the p-value, it should be less than 0.05. We can say there is a relationship between the variables, but your p-value is here that significant value is more than 0.21. Okay, so you are rejecting your you are accepting your null hypothesis. What is null hypothesis? There is no relationship between these two categorical variables, achievement, motivation, and division. Likewise, we give a conclusion, right? So finally, what you can conclude? We conclude that there is no significant relationship between or association between these two categorical variables, achievement, motivation, and academic performance or academic achievement. Fine. In this way, we can write the analysis or we can discuss the results and we can write the uh, results and discussion. Okay, yeah. So now I'm going back. I'm going back, please. Yeah, now here uh, several statements are there. Okay, so I'm taking another one is test whether there is any relationship between the marks in mathematics and marks in English. Yeah. Now marks in mathematics, this is one variable, and marks in English another variable. Okay, this is now quantitative. No, marks are interval scale. That is uh, marks are uh, quantitative and continuous, right? So when marks are quantitative and continuous, then also you can test the relationship between these two, that is mathematics, marks in mathematics and marks in English. Again I am going back to my SPSS data file, please. Right, so now I'm going to top menu, analyze. Okay, now our interest, our wish is to test the relationship between these two. Again you go to your correlation tool. Okay, then again bivariate, because you have only two the marks in two subjects like x and y, or marks in mathematics, marks in English. Okay, now you can take the bivariate. Yeah, just you can reset, because earlier we have done that achievement, motivation, and division, academic performance such as division. Now you can reset your variables. Now I am resetting marks in mathematics, my first variable. My second variable is marks in English. I am taking marks in English. Now our wish is to test the relationship between these two. Now again I am taking the mean and HDs. Of course, if you want to analyze the covariances between these two subjects, then you can take the cross product deviations and covariances. Covariance will give you the joint variation between the marks in two different subjects. Here, this is nothing but an intermediate step while calculating the correlation to analyze your data. Okay, I'm not taking this cross product deviations and covariances, right? Yeah. Now continue. Okay. So again the Pearson correlation. Okay. So if you want to use Kendall and Spearman, you can take. Okay, you can take on it. Then now you okay. Say okay. Fine. Yes. Now you can see. Now you can see the correlations. What are the correlations and what are the descriptive statistics? Fine. Just in output window, in output view, see the descriptive statistics. Marks in mathematics, average marks 18.62, marks in English 14.12. Right. Now you compare the marks in mathematics and English. What are the average marks? Where the average marks are high, in which subject the marks are high, like that you give. Okay, marks in mathematics, marks are high compared with the marks in English, right? The variation could be the variation between marks in mathematics and marks in English. The variation that is measured by using the standard deviation, right? The standard deviation for marks in mathematics is 3.73. Marks in English is 2.18, right? Now the variation between the marks in mathematics is more compared with English. Likewise, you give an analyte. Okay, now yes. Now our wish is to know the correlation. No, our interest is to test the relationship between marks in mathematics and marks in English. Yeah. Now come here. See, I will look marks in mathematics with marks in English. The correlation is very less. Again, it is 0.035. Fine. Yeah. Now the significant value you can see 0.726. This is p value. It is very high. Okay, p value is here should be greater than 0.05. Okay, just now I have told your p value is less than 0.05, then your relation is significant. This means marks in mathematics, the relationship between marks in mathematics and marks in English are significant, right? And finally, you give the conclusion like marks in mathematics are high compared with English. Likewise, we give a conclusion for this. But here you did not get the significant relationship between marks in mathematics and English, right? Yeah. This is the way to know the relationship between two variables. Even you can extend this for the multiple variables also. Fine. Instead of taking marks in mathematics, marks in English, you can take marks in physical science, marks in social science, marks in some other subjects also. Okay, this is the way to test the relationship between the variables. Now I go to my practical exercise, and I mimic with my another hypothesis. My another hypothesis is I am taking yes, examine the relationship between the student academic achievement and achievement motivation. Sorry, yeah, just a second. I'm going to my practical exercise 7. Yeah. In this slide, your first question, that first hypothesis is test whether the 100 students randomly selected come from a longer group, of course, a population of students having mean academic achievement score of 75%. Here I am taking percentage of marks. Here it is given 75% uh, mean scores were there, that large group of students, and the number of students are 100. Fine. Now here we need to set up the hypothesis. Okay, I am setting up the hypothesis like that. My null hypothesis is the mean academic achievement score of these 100 students is 75%. Okay, so this you call population mean. Okay, so that is a longer group you are taking now. Yeah, of course. So your hypothesis is now mean academic achievement is 75%. Alternative hypothesis is mean academic achievement score is not 75%. Like that, just you can set up the hypothesis. And now you go back to your SPSS data editor. Okay, go to your data view. Okay, so then again go to top menu and see analyze. Click on that. Now your interest is to test the mean academic achievement is 75%. No, that is percentage of marks. Mean percentage of marks or average percentage of marks is 75%. Right? This is confined with the mean. So that's why just you go to descriptive statistics, then tables, then compare means. Now you can see. Just I'm talking about mean now. Now you compare the mean. Now you can have only one mean, right? That is mean score. Academic performance, mean performance score is 75%. Okay, this means we can have only one data set with a single variable. What is that variable? That is percentage of marks, right? Now our interest is to test the mean. No, then you go to this means test. Okay, now you can see. Now you can see what are the dependent list. Fine. Now yeah. Oh, I'm sorry. I'm sorry. Just I'm coming back. I'm coming back. Yeah. Yeah. Compare means that is one sample t-test. Okay. So here t-test is a tool which gives an idea how to test mean of the population, mean marks of the population, mean marks of the students in a particular subject. Okay, so that is a inferential statistics tool based on the sample. Here the size of the sample, of course it is large even I am taking the t-test, right? Yeah. So what is your test variable actually? My test variable is the percentage of marks, that is academic performance. Okay. Now you click on that percentage. Now this is your variable. What is the test value? Our interest is to test whether the marks are 75% or not. That's why just you should input here, plug in the 75 marks. Fine. Now options. What are the options here? Confidence interval is 95%. Okay. Yeah. Here what is the meaning of this confidence interval? Here, in order to solve your hypothesis testing problem, in order to test your hypothesis for your problem, just your confidence level is 95%. Okay. So there are different confidence levels we can have, like 90%, 95%, 98%, and 99%, right? Here you are testing your statement or statistical null hypothesis with a 95% confidence level. Okay, there may be chance to losing the confidence is 5%, right? Now I'm continuing. Go and continue. Then click OK. So what is happening? Just you can see, please. In output view window, it is have a look that one sample statistics. This means for your variable the percentage of marks or academic performance. What is the strength of the class? What are the average marks? What is the standard deviation of marks? And what are the standard error for mean? It will be displayed. Okay. So just you should concentrate on average marks and standard deviation. But our wish is to test 75% of the students are academic performance. The academic performance of the student is 75% or not. That we are testing, Yeah. So that's why just with the one sample t-test, the one sample t-test has given these results. So these results now, yeah. So your t-test value, okay, this is computed by using the small sampling t-test. That is of course 11.778. Okay, this is the degree of freedom. Just you should concentrate on the significance level. The significance level is now is very high. Okay, so the p-value is very less. This means, so p-value is less than 0.05. This means what? So there is a lot of chance to reject your null hypothesis. What is the null hypothesis? 75% of the academic performance of the students. Okay, so just I'm doing that, sorry. Yeah, mean academic achievement score is 75% or not, right? Yes. Now yeah, you can see the significance is very high. Okay, so now you can reject your null hypothesis. Okay, so the academic achievement is not 75 75%, right? So is not 75% in the sense what, that may be below 75% or that may be above 75%. Just you can see the mean marks, that is 66.45 now. Yeah. So now you come to the confidence interval different. Okay. Yeah. Now what is the confidence interval for the mean difference between the marks? So that is 7.11 to 9.99. That is the difference in between the mean. Okay, 95% confidence interval of the difference for the means compared with your null hypothesis, right? Yeah. Now I am going back to my exercise. Yes. Now examine if uh, there is any significant difference in total marks among boys and girls. Examine if there is. I am sorry. Yes, this is. There is any significant difference in total marks among boys and girls. Right. You can take total marks of boys and you can take total marks of girls. So, is there any significant difference between the marks? Okay. Then you go back. Then here you can have two samples. Now, boys you can treat one group and girls you can treat one group. Right now you can have two different groups. Now our interest is to test the significance difference between the total marks in between boys and girls. Right? Yeah. Now I am going back. Just this is my um, data file, data editor. Now go to analyze. Right now we are testing the significance difference between the mean marks of boys and girls, no, or total marks in between boys and girls, no. Just I am taking the mean marks, no issue. Now earlier I have I have considered one sample t-test. Now I would like to consider independent sample t-test. Why it is independent? Boys and girls both are different. There is no relation. So independent sample t-test. That's why I am taking independent sample t-test. Please try to remember that this independent sample t-test is nothing but t-test for difference of means. T-test of difference of means for what? Boys and girls, right? Yeah. Now just I am going my marks. What are the marks? Where the total marks, right? Yeah. Now I am taking this, right? So total mean marks, of course. Total marks in the sense total mean marks. Now you can take this variable. Fine. Next, grouping variable. What is grouping variable? Grouping variable is one group is boys group and another group is girls group. No. So now that is gender classification. You have a variable gender now, then you go there, right? Now gender. So now you give this, right? So now you define the groups. How you can define the group? Group 1, that you can say 1, that is boy. Then group 2, that is female, no? Then you give girl. Right? There is no question of cut point. Then continue. Right? Now options. What are the options? If you want to test the significance with a 95% confidence level, you can take 95% confidence level. Okay, if you wishes to test your hypothesis with 90%, then you can take 90%, nothing to bother. Now continue, then come back, then you can say okay, fine. Now here see in output view, okay, the t-test calculations, the complete summary. Okay, it's displaying. Now group statistics. Yeah, group, that is boys and girls, no, male and female. Fine. So how many number of boys are there? There's 64. How many number of girls are there? That is 39. Okay, their mean marks are 64.69. Girls mean marks are 62.39. Okay, 38. Sorry. Now the marks, the total marks of boys are more now compare with the female girls, right? Yes. Now see, now here we have taken two different test procedures. It has been given an idea with the F test and T test. T test will give you the significance difference between the mean marks of the uh, boys and girls. Okay, it gives us an idea the significance difference between boys and girls, right? Now F test statistic, please you can have a look here. The Levin's test for the equality of variances will give you, is there any significant variation between the marks of boys and girls, right? Yeah. So this will give you an idea about the variance, significant variation in between the groups, and this T test will give you, is there any significant difference between the mean marks of the students, like, yeah. So now you see, you can have a look, right? Yeah, the significant value is 0.1 in both the cases, right? 0.1, 0.13. Okay, both are I mean uh, for means, for variances, in both the cases it should be greater than 0.05. For equality of variances, Okay, and for difference of means. Clear? Yeah. So in this way, P is not less than 0.05. There is no question of having the significance difference between the marks among between boys and girls. This kind of an idea we will give easily, right? So this is the comparison of marks in between boy students and girls students with the help of t-test. That is two sample t-test. Fine. Yeah. So I go to my exercise. Yeah. Now another one is if students take private tuition, they would have better study habits than compared to students who do not take private tuition. Yeah, examine. Yeah, what is this actually? We need to test. Is there any significance difference between the private tuition, whether they would have better study habits compared with the who do not um, taken the private tuition? Fine. Yes. Here now our interest is to test is there any impact of uh, taking private tuition on study habits. Right. This is the statement actually. I would like to set up a null hypothesis. There is no impact, significant impact of private tuition on study habit. This is my null hypothesis. And you can set up the alternative hypothesis is there is a impact of private tuition on taking private tuition on study habit. Fine. On the other hand, you can set up your null hypothesis like that. There is no relationship between taking private tuition and on improving the study habits. Fine. In that way, you can examine. Now, how you can test this significance difference between this taking private tuition impacting on study habits. Okay, now here both are categorical variables, right? So taking private tuition, not taking private tuition, fine. And in case of study habits, you can have low, high, of course, more. Sorry, just we go there, please. Yeah. Now I am coming back to my data file, and just what I am doing is uh, descriptive statistics, that is a cross tabulation. Okay, we have to test whether is there any impact of private tuition on the study habit. So now go to cross tabulation menu. Now row, what is row? Yeah, you can take that is the variable is categorical variable is tuition, column is study habit category. Now the column is study habit category. Fine. Now we are tabulating, that is cross tabulating the rows and columns with one test procedure or tool. That tool is nothing but chi-square test. Here the chi-square test is a non-parametric test to test the significance difference or to test the relationship between any two or more attributes. Here, of course, the tuition and study habit category. These two are two different attributes, right? Two different categories. Of course, categorical variable. Right now, how you can mimic or cross-tabulate these two, and how you can analyze with the tool that chi-square test. See, now what is the exact test? This is about the simulation like Monte Carlo, of course, asymptotic only. Nothing to worry about this. Just you can say continue. Then come to statistics. The statistics is chi-square, please. If you want to know the relationship between these two, you can take the relationship. Okay, that is it also compute the correlation. Now our interest is to test is there any relationship between these two. No. Yeah. Now yeah, just you continue, you should continue, then comes to cells, then you can have a look here please. Yeah, if you want to get the percentage for rows and columns, you can take percentage for row, then column, of course even then uh, for total also. Okay, in this way it will give you the uh, percentage, of course percentages and the respective frequencies for tuition and uh, habit of your study category. Fine, now you should continue. Yeah, now yeah, it if you want to display clusters bar charts, then you go. So I'm not interested on this chart wizard bar charts. Just I'm directly I'm going in, click on OK. Fine, yes. Now you can have the output for your uh, data set, that is a relationship between the two categorical variable, that is tuition and taking private tuition, and another one is study habit category. Please try to understand here the cross tabulation analysis between taking private tuition and study habit category. Fine, yeah. Above is case processing summary, nothing to worry. This is total strength. Valid percentage is 100. Anyone observation is missing or not? Just you can see there is no question of missing observation. Then come down, can see the cross tabulation, complete cross tabulation analysis of taking private tuition and the habit uh, category of your study. Fine, yes. Study habit category is having three subcategories again, that is three different levels: low, moderate and high. Fine, then taking tuition, private tuition, and does not take private tuition. Fine, now please try to understand this uh, cross tabulation analysis in between the private tuition and habit category, study habit category. Clear? Yeah. So just you can see please, my concentration is on now taking private tuition and study habit category, that is low, moderate and high. High on study habits, the 28 students are there. The percentage within study habit category and high is 51.9 percentage. Okay, this is within tuition, and within study habit category, that is now 70% of them uh, are in high on study habit, right? Of course the total is it is given within the count is 54. It is very high. It is high compared with uh, the does not take the private tuition, because this is 46. This is comparatively high. Fine, yeah. In this way, of course, is there any significant impact of taking private tuition in order to improve the study habit? Yeah. So by frequencies, by percentage, of course there is some impact with the private tuition on study habit category. Fine, yes. Whether you have the significant relationship between them or not, just you come and check. Just you can see the chi-square test statistic. The chi-square test statistic value is 7.94. The value is high, then there may be chance to there may be chance to get the highly significant. Okay, so now you can see the Pearson chi-square value is this, and the significant value is 0.019. Please try to understand again. This is less than 0.05. What is that 0.05? P value, probability value. What is that probability value? Once again, I am repeating: probability of rejecting your null hypothesis. What is probability of rejecting null hypothesis? Probability of rejecting null hypothesis when null hypothesis is true. Okay, so you are saying you are rejecting and you are saying that it is true. That is absolutely wrong. So that's why your p-value is now less than 0.05. Means what? You are accepting your alternative hypothesis. What is alternative hypothesis? There is an impact of taking tuition, taking private tuition uh, gives there is a change in habit of your study. Okay, habit. What is it? Just a second, please. Study habit category. Yes, it is low, moderate, and high. Now, from this, you can easily say taking private tuition gives high. There is an improvement on study habits. Fine. So this is a way to give the conclusion by using the cross tabulation analysis with the help of non-parametric chi-square test. So this is very important to you people, okay, because this program is a ELT program now. So this kind of categorical analysis, cross tabulation analysis is very important. Okay, so a lot of priority will be given for this kind of studies. Chi-square test, non-parametric test is very important for our behavioral studies, or if your study is a, a categorical uh, variable, having categorical variable, or having categorical group. Okay, yeah, fine. Now I'm going back to another question, one more question. The statement, yeah, yes, 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 yeah, yeah. Now what is this? Yeah, practical exercise 8. Just here I have put on my slide 8 questions. So we'll discuss one question so that all remaining questions it is easy to test if I explain one. Okay, examine if there is any significant difference uh, of academic performance of students belonging to their different sections. Fine. Yeah, academic performance is one variable here, right? Yes, there are three different groups, three different sections. Yeah, section A, section B, section C. Here, the hypothesis is there is no significant difference between the academic performance of the students belonging to the three different sections A, B, and C. Right? Yeah. So my interest is there is no significant difference between of course mean academic performance I am taking mean academic performance among three different sections now. Yeah. Now this is more than two groups. If you can have more than two groups, then we go for analysis of variance, right? The ANOVA tool or analysis of variance tool or technique will give you how to test the significance difference between the one variable, that is academic performance, among of course three or more groups even, right? Yeah. Now I am going back to my SPSS data editor, data set. Okay, so now again you go to top menu, analyze, fine. Yeah, now you are testing is there any significance difference between the mean performance among three different sections A, B, and C. No, yeah. Now we're going to test that is more than 2 minutes. Here the ANOVA tool, one statistical device. The ANOVA tool will help you, will give you an idea how to test the multiple comparison. Okay. So now our wish is to test if there any significant difference between the academic performance of the students among three groups: section A, section B, and section C. Right? Yeah. Now just the tool is one way ANOVA. No? If you can have another variable with two different, then we go for two-way analysis of variance, right? Here only you can have single variable and single factor, that is group. Fine. Now, now dependent list. What is the dependent list? The dependent list is your academic performance. Fine. Here I am taking the academic performance is a percentage of marks. Okay, percentage of marks. Where it is? Yeah, percentage of marks. Of course, you can take total marks also. No problem. I am taking the percentage. Yeah. Now the factor. What is the factor? Factor is nothing but uh, section. Okay, group 1, group 2, group 3 like. Okay, so section, you have three different sections now. Section A, section B, section C like. Yeah, three different sections. You treat three different groups. Okay, now factor is now the group. Fine. Yeah. Now you can test the uh, uh, analysis of variation uh, in lines of that is academic performance uh, among three groups. Okay, three different sections, right? Yes. Now the variable dependent list, the variable is percentage and the factor is your section, your group. Okay. Now contrasts. No need to do anything here. Just you go as it is. No need to take that contrasts here. I'm not concentrating on that now. Okay. Then you can take options. See, what are the options? If you want to know the descriptives, then it gives summary of the data. Descriptive in this sense, right? Summary of the data. Okay. If you want to get the mean plot, then you can. Otherwise, no need to take. Okay. Then continue. Okay. Yeah. If significant is there among the groups, then we go further. How much in which group you can have the significance difference. Okay, we have the significance difference in between A and B, B and C, or section A and C. That's why just you can extend the analysis of variance with the post hoc test. Okay, so I am clicking on that post hoc test. There exists several post hoc analysis tests for the data analysis in SPSS tool. Okay, so here most of the times usually we do that least significance difference. Okay, some people they can do the tricky. Okay, tricky. Some people they can go for Waller and Duncan. Okay, some people go for Sheffield. Okay, so basically, of course, most of the times the popular post hoc tests are LSD, tricky, then Sheffield. Okay, so now I'm using here the least significance difference. Okay, if you want to test the validation, then you go for Sheffield or Tukis. Okay, I'm not taking that one. Okay, now, okay, of course, if the variances you're not assuming that the variances are equal. Okay, if variances are not equal, then of course you can use any one of the following post hoc tests. Okay, now that is Temhanes, Dunets, Games. Okay, Donets T3 and Donets CC. So these are four different tests which we can have in post hoc analysis for equal variances or not assumed. Okay, and my significance level is 0.05. Okay, now yes. Now you go and continue. See, now you can say okay. Yes, yeah, wonderful. Now these are the output tables of ANOVA one-way classification. Fine. Yes, in output view, the first table will give you summary of the data. Okay, that is descriptive measures. For what? For your group. How many groups you can have? Three groups you can have. Section A, section B, section C. right? So how many number of students are there in section A? 30. How many number of students are there in section B? 34. In section C, 36. Like their mean performance. Okay, now that's percentage, right? So 64.97. Here it is 73.28. 28, sorry, 61.23, like then standard deviation, then standard error, then confidence interval for them, then minimum observe, minimum percentage, then maximum percentage, like that. Okay, minimum percentage in section A is 52 and maximum percentage is 76. Likewise, it gives you the descriptive analysis or basic analysis, right? Now comes to here. Now ANOVA. So your variable is what? Academic performance in percentage. Fine. Now this will give you analysis of variance. Is there any significant difference between the variation of your groups within the groups? Means what? Here between the sections and within the section. See, between the groups. Between the groups means what? Section A and section B and section C. That is between the groups. There may be a chance to have the variance of percentage of marks between the groups. Fine. Yeah, within the groups. What is this within the groups? Yeah, within the group. You can take section A, my first group. If you can take the section group A, you can take the academic performance in percentage, right? So there might be a chance to vary the percentage of marks among the students. Okay, no, among the students. Okay, so how many number of students are there in section A? 30 students. So for these 30 students, now there could be some difference in percentage of marks. So that is nothing but the variance. So now here the variation occur between the groups and within the groups, right? Now you can take the ratio, okay, with respect to the degree of freedom. So these are the degree of freedom. How many number of groups are there? 3 groups. Okay, so now degree of freedom, here it is n minus 1, 3 minus 1. Here how many number of students are there? 100. That is total number of observations of strength of the class, right? How many sections you can have? 3. So now you can subtract 100 minus 3, that is now 97. Now what is the total group? Total group is 100, right? So from that 1 degree of freedom is one observation you can extract. That now the degree of freedom is 99. Please, you no need to remember all this. Just you should concentrate on your test. That is F test. Already you have an idea what is the use of F test. F test will give you an idea about how you can test the variation of the data for given two data sets. Fine. Yeah. Here the p-value is very low. Okay. So that is p-value is less than 0.05 and it is 0.000 something. It is highly significant. This means what? You're rejecting your null hypothesis. What is your null hypothesis? The academic performance of the students among the 3 sections are same. Okay, that is your null hypothesis. But what is happening now? You are rejecting because the value is highly significant. That's why you are accepting your alternative hypothesis. What is that alternative hypothesis? There is some significance difference between the academic performance of the students in 3 sections. Okay, yes. Now the question is, yeah, now from the analysis of variance one-way tool, you got an idea. Now there is a significant difference between the academic performance among these 3 groups. Okay, but if you compare 2 groups A and B, now how much significance is there in academic performance, and what are the significance difference of academic performance interval, right? That is interval scale, like confidence interval. So now for this purpose, just I moved on to use post hoc test. We have used here. We have applied the first post hoc test, very popular post hoc test, that is least significance difference. Yes. Now here the dependent variable, of course, study variable is here academic performance, right? The academic performance, that is in percentage. Now least significance difference. Now it has been given. See, now section A with section B, what could be the mean difference? That is 8.31. Okay, mean difference I am taking here. The minus is negligible. No need to take that minus into an account. Fine. Yeah. Then forget about the standard error here. Okay. Now what is the significance level? Yes, you can see significance level is 5%. Now the value is very low. The p-value is less than 0.05. Then this is highly significant. Now there could be significance difference in between the academic performance of the students between section B and section C. Right. Section A with section B is how much? Difference is 8.31. Okay, what is the least one is 5.75 and highest is of course 10.888. Okay, you ignore that minus place, then you can take this lower bound 5.75 as a lower bound and 10.88 as an upper bound at sorry, with 95% confidence interval. In that way you compare with section C. Of course there is mean difference is 3.73. Of course again this is also significant, and the interval mean interval academic performance is 1.21 to 6.27. This is the difference. Fine. So now again B with the A and C, C with the A and B, all are same. Okay. So now finally you could observe that there is a significant difference uh, between the academic performance of the students among three sections A, B and C. Now you can tell, you conclude that section C, section A mean marks are 64.97, section B 73.28, section C is 61.23. So now section B students are high academic performance. Okay, so on the other hand, section B students are somehow intelligence compared with section A uh, and section C. Okay, section B students' performance is more compared with section A and section C. So this is the beauty of analysis of variance and how you can use the post hoc tests, right? Yeah. So this is yes. I'm going back. Yes, these are all other questions I have put on my slide. Please, you can practice. You can take one hypothesis and you can practice. You can mimic with your data using the SPSS uh, tool. Okay. Yeah. Now anyone you can take and you can test. If you can have any doubt in this, any question, any statement, that I will explain how you can test. Okay. Yeah. Yes. Now. Yeah. This is of course feedback. Give feedback to me on this mail ID and visit my site on this. This is my Google site. I have put on Google site every video lecture, assignment, worksheets, SPSS data files, FAQs, okay, and my videos. Okay. uh, get you back within 5 minutes. Thank you all for listening patiently. Thank you very much.